Okay, today I'm going to lecture about cognitive diagnosis models. There is a package called CDM that you can find some information here about this package. Needless to say that you should first install it through the install package command. The cognitive diagnosis modeling provides you with some kind of compensatory and non-compensatory models that help practitioners to specify the underlying skills and attributes for the students to answer test items correctly. So it is a methodology that is so similar to mixed methods because researcher should first run a qualitative analysis and qualitative research through, for example, thinking aloud protocols for the students or doing doing some interviews for expert panels about the underlying skills and attributes of a test and specify which item of the test actually are related to which skills that students should possess to answer the test items correctly. So there are two kinds of compensatory and non-compensatory models for cognitive diagnosis modeling. For example, the DINA model is a model that the corresponding algorithm is relevant to the compensatory model. The compensatory model tells you about the skills that contribute to answering a test item correctly. And for example, in the DINO model, that is a compensatory model, the skills needed for answering a test item correctly compensate lacking each other. For example, when we, for example, in this package for this function, for example, in this function we have a sample IQ matrix that is called fraction subtraction matrix. Fraction subtraction matrix, it's a Q matrix that's already specified by experts, and the researcher already specified the matrix. The alphas here, the alphas 1 to 8, representing the skills of the students required for answering test items correctly. For example, this is a 20 items test that is about fraction subtraction. Fraction subtraction tests are about subtracting fractions in a math test. For example, we may ask a student to subtract the 4 over 3 we subtracted from 7 over 4. This is a fraction subtraction question like that, and there may be other question more simplified or more complicated than this question. We have 20 items like this, so uh, you can see that 8 skills are required for answering these 20 test items correctly. Okay, let me run just this model here and tell you which skills are required for this model. If I plot this model that I ran here, I named it fractions Dina model. If you plot for this, you can see some plots. For example, this is the item index plots for guessing and non-slipping probability, and this is the uh, these are the skills. This is the alpha 1 skill, this is alpha 2, and for alpha 8, for example, the skill 1 is convert a whole number. This is the first skill required for example, answering item 1, for example, answering item 7, for answering item 7, the alpha 1 or the skill of converting a whole number is required. The second skill is also required. The second skill is separating a whole number, and so on. So, according to this matrix that is already specified by expert panels, or it is maybe a product of a qualitative research like thinking aloud protocols of a student. For example, in the thinking aloud protocol design, we ask a student to answer the test items and think. We ask them to think aloud when they are answering the test items. So through these thinking aloud processes, we find out which skills from these skills that already specified by the expert panel are required for answering each item. So the main goal of cognitive diagnosis is actually to determine the skills and specify the relationships of the skills to the items through the Q metric, then run the compensatory and non-compensatory models for the cognitive diagnosis model. So the compensatory model, like Dino, is about the role of these skills on answering test items. In the compensatory model, lacking one skill may be compensated by remaining skills. For example, if the student doesn't master to the fourth skill, but he or she is mastered on the skills 6 and skills 7, she or he still has the chance to answer the test item correctly. In this case, the lacking skill is compensated through the other remaining skills. Okay? But in the non-compensatory model, like the DINA model that we ran here, the rule for running of the model here is the DINA model. In the DINA model, lacking one skill is equal to lacking all of these skills. So the remaining skills cannot compensate for lacking one or another skill. In this case, for example, we are going to run the compensatory and non-compensatory model to first search for the optimum model, a compensatory model like DINA or a non-compensatory model like DINA or a compensatory model like DINO. So the model that yields us a better goodness of fit indices is the optimum model that should be reported. So the process of cognitive diagnostic modeling is to find the optimum model. And the criteria for selecting the optimum model is the goodness of fit measures that we are going to talk about it in the next episode of this educational video. Good fortune.